This session is about smart contracts and decentralized autonomous organizations. We have a number of very interesting speakers lined up. Our first speaker is Jens from ETH Zurich. Jens has been very prolific, very fruitful in blockchain research in relation to the built environment and in relation to construction project management. And it's a real pleasure to have him here showing his latest research. And his talk is entitled Digital Building Twins and Blockchain for Performance-Based Smart Contracts. So Jens, thank you for being here today, and welcome to your talk.
Hello, thank you for having me. I'm Jens Hunhevicz, Chair of Innovative and Industrial Construction at ETH Zurich, and I'll present you today some of our latest research that just got published and fits very well in this CPC event this time. So thank you very much for the opportunity. So there is a lot to cover in this paper. I'll only touch some high-level points that I think are super interesting. If you want to know more, you can always read the paper. It's open source. It's accessible under this link. And also shout out to my co-author, Meshit Motye and Daniel Hall. Without them, this research would not have been possible. So we explored performance-based contracts in consideration of the energy performance gap. The energy performance gap is something that can be observed over and over again, that we push for more green buildings. But in the end, when they are built, the actual energy usage is way higher than the predicted energy usage. And this is not the fault of one party, it's more a systemic failure of how the industry works. I don't want to go into too much detail here, but in the end, performance-based building is seen as a promising tool to reduce this energy performance gap by financially incentivizing parties to deliver a building that meets the targeted performance levels. So this is not a new idea. This idea has been around for quite a while. We already heard about it also yesterday from Richard Saxon, and some others mentioned it too. So really not a new idea. The benefit of, or the idea that performance-based contracts can improve the situation comes from, can be understood when we understand how traditional projects usually work. So usually an owner pays a capital sum for a built asset, and then over the life cycle, the owner is responsible for financing the operations, maintenance, disposal of this built asset, or also one technical subsystem. This gives little incentive for everyone else that is involved before that to design and build for the best possible life cycle performance. In contrast, when we consider this new opportunity of performance-based contracts that are part of this business model servitization, then it's a bit different. The user only pays for the provided services, and ownership and responsibility for operations, maintenance, and disposal stay with the producer. In contrast to manufacturing, this can be a bit more complicated in the built environment. We usually not only have one producer, but multiple ones. So, and that's also one reason why performance-based building is not so widely used for now. But the actual idea stays the same. You have to give incentives to design and build for the best possible performance, because the actors benefit directly from this. There are already I mentioned there are a couple of challenges related to that, and I'll focus here, of course, on some that I think new technologies like digital building twins and blockchain can solve. One challenge that gets mentioned often is that actually we need performance data to base performance-based contracts on, so we know what's going on. And some other challenges get mentioned often is the lack of confidence into these new serialization models, and this boils down to accountability issues, maybe over long time spans. You're not sure how long is someone involved, who is involved at what stage, because these like build assets run for or get operated for quite a long time. And then there are also some financial hurdles, and it's often not perceived as very attractive business model. And we think that, and Richard Saxon already mentioned some of this yesterday too, digital building twins and blockchain might be an opportunity to make this a bit more attractive. So to summarize, digital building twins provide this real-time data baseline for performance and can predict and measure performance accurately and equitably. And blockchain and smart contracts then provides the opportunity for a trustworthy performance history, transparent performance criteria that are hard to change once defined. So we can address maybe a bit this accountability issue. And there is opportunity for new financial models and business models with pay-per-use and performance with real-time incentives and payments using cryptocurrency and tokens. So that's not new. Others have thought about that too, but what we tried is actually to build this. We tried to choose the easiest way we could see, and we came up with this technology stack, where on the left you have the physical world, the actual building equipped with sensors, and the stakeholders that are involved with this building. And then in the cyber world, you have the digital building twin, which is the green circle, encompassing sensor data, digital models, and of course, some cloud infrastructure from the digital building twin provider. In our case, we based our solution on the Siemens Building Twin platform. More on that later. And the other key part is the smart contract. So we had a blockchain with a blockchain node that we connected to, and then we were able to interact with our performance-based smart contract that we coded. For the connection, we coded some middlewares we call backend Oracle and frontend Oracle. The backend Oracle connects to the digital building twin over APIs and also to the blockchain node over APIs. So it's like this middleware, and the frontend Oracle ensures that users can access or interact with the smart contract through a visual user interface. So they can set up rules and payouts and stuff like that. So I want to show you how we thought about this and how we built our smart contract. So it uses different blockchain affordances or pieces like addresses, tokens, smart contract functions, and smart contract storage. And then, we assigned roles, and of course you need roles because you need a smart contract manager that kind of sets up this, or more managers. There can be multiple ones. And then of course the stakeholders and the users, all of them have addresses that need to be recognized by the smart contract. And then you have contract logic that defines permissions, who can do what in the smart contract, performance terms, what's the performance baseline and logic, and then the payout logic that's then connected to the escrow amount that is held by the performance-based smart contract, and then does payouts if performance levels are met. And of course, there is some data in smart contract storage that is inevitable. For example, the sensor IDs, the backend, and the roles, they need to be registered through the front end. So only these parties can interact with the smart contract. But then there is performance terms need to read the performance data. And for now, we saved all the data in the smart contract that is fetched through the backend Oracle from the Siemens Building Twin platform. More on that later. So that's how we built the smart contract. We then did a proof of concept. We chose Aspern Technology Center 2. It's in Vienna. It's a real building that uses the Siemens Building Twin platform. And we then created a cross-phase thermal performance smart contract to kind of address the energy performance gap problem. So the workflow goes something like this. In the early phase, you define thermal performance logic that you want the building to have, and then set up the smart contract, register the users that are already in that phase involved, like the owner and the contractors. Then you fund the escrow, and then when the building is built, of course, hypothetically, it was built already, then you register building and sensors. And then you register the other party, the facility manager, which was also part of our smart contract structure or logic. And then you run the smart contract and deactivate it in the end. All right. So we thought about some performance baselines that is related to energy consumption of the building. This it relates then to the contractor to give them an incentive to design for the best possible energy performance. But then in the operations phase, the facility manager is responsible for thermal comfort in the building related to temperature, relative humidity, and CO2 concentration. And then we defined some logic in what cases it's whose failures. And oh, that was the wrong direction. And well, I can't go into too much detail, but in the end, we defined certain ranges, and if they were in this range, they got payouts, and if they deviated from that range, they got a reduced amount or no amount. All right. Here you see the technical infrastructure, how we built this. We use the Ethereum stack with tools that are quite common, like Infura to connect to a node, the Web3 library to interact with blockchain, with the Ethereum virtual machine, and MetaMask as a crypto wallet. And on the backend side, we had the Siemens Building Twin, and we had a server running on Node.js. There is two main steps. The first green circle you can see here is kind of setting up everything. So register all the addresses, and then when everything is ready, you move towards running the smart contract. So then the data gets fetched and the logic assessed, and payouts get created. So I have a short video which is probably illustrates better what we have done instead of this theoretical visualizations. So you can see the Siemens Building Twin BIM model, and then the sensors that are located in the building can be accessed over the Siemens Building Twin platform, and the data can also be streamed over APIs from that database. We then deployed the smart contract to the Ethereum test network. We didn't have money for the main network, but it's about the same. And then we registered the case, so the users, the sensor IDs, and so on. And when everything was ready, we started streaming the data. And we ran this over only 2 days instead of 6 months because we didn't have too much time. But we just sped up the collection of data points. In the end, everything worked as expected. Of course, the performance analysis is not really meaningful because we sped up everything and it was only over 2 days. But what we could observe that was interesting is the transaction costs. If we would have deployed that to the mainnet, it would have cost around $40,000 US. So it's quite expensive. Yeah. Well, this, of course, can be discussed. What can be done about it? Overall, we think it's not really feasible to have these performance-based contracts on the mainnet, or at least on the first layer blockchains. But I'll come to this now. So the key takeaways I wanna give you is that overall, I think it's promising a DLT use case for the built environment. To align performance incentives with crypto economics and hold parties accountable through affordances like transparency and immutability that blockchain can offer. The technical setup is feasible, but of course with many limitations. Both the state of blockchain and building twins is quite early, but this is expected to improve over time. The hardest thing was to set up the performance baselines and appropriate rewards. We were a bit lost there. We tried our best for this use case, but yeah, I think someone needs to think about how can you make this profitable? What's an appropriate reward for a certain performance baseline? So we had actually no idea, and we just did our best. So I think it's actually this needs to come first before you actually can have building performance-based smart contracts in the end. I think the technicalities can be solved. Having said that, there are some key challenges. As I said, transaction costs on the main layer is not really feasible. Of course, there are many options. Could go off-chain. You could use second layer scaling solutions like we've heard in previous presentations. There are many options, but these need to be explored. what makes sense in the end. Or you could also use another blockchain than Ethereum. Maybe that's also a solution. And then one tricky thing is the dependency on these third-party services, because blockchain itself is very secure, but then you connect to somewhat centralized services like the digital building twin platform. And the connection between these services is not too easy. It's how do we ensure actually this trusted data exchange between these solutions? It's not so straightforward as well. But I also think there are options and solutions there that need to be explored. So that was a very brief overview of our research. As I said, you can read more in the paper or approach me later. Thanks for your attention.